current, according to nature of current, according to type of construction, according to scheme of connection. This is classification. Distribution system classified according to three categories: according to nature of current, according to type of construction, according to scheme of connection. What is according to nature of current? There are two types. According to we are using AC distribution and DC distribution. According to nature of current, they are classified into AC distribution system and DC distribution system. Okay. According to nature of current, there are two types. According to nature of current, what type of current you use? AC current, DC current. AC distribution and DC distribution. According to type of construction, how to transmit the power? According to type of construction, how to transmit the power? There are two types of transmission: overhead transmission, overhead transmission system, underground transmission system. Okay. According to scheme of connection, scheme means method. According to scheme of models or methods, according to scheme of connection, they are classified into number one, radial system. Number two, ring main system. Number three, interconnected system. Okay na? Distribution system classified. Distribution system classification according to nature of current, according to type of construction, according to scheme of connection, according to type of current. What type of current you use? AC current or DC current? So AC distribution system, DC distribution system. Okay. According to type of construction, how to transmit the power? What are the ways are there? There are two types of ways: overhead transmission system and the ground transmission system. Okay. And according to scheme means model, scheme means method of connection. Scheme of connection means radial system, ring main system, interconnected system. Okay. So AC distribution, alternating current distribution system, DC system, direct current distribution system. Okay. Which one is the better in both AC and DC? Okay. AC means three phase, one neutral is there, three phase, four wire system. Okay. DC means in our laboratory, DC experiments are there. Okay. What is DC? Here two conductors, positive polarity, negative polarity, plus minus is there, DC. In case of AC system, R, Y, B and one neutral is there, three phase, four wire system. Okay. So compared to conductor cost, compared to their economic concentration, which one is the better? DC. DC because DC only two conductors required, positive, negative. Here the AC three conductors, from neutral is required. So conductor cost, copper conductor cost, throughout the length. So due to economic cost wise, AC, DC is better, AC is costly. Okay. So in sometimes DC, only one conductor also used. Positive polarity, earth is treated. Earth treated as negative polarity. Okay. Only one conductor also possible to transport. In case of DC, which one is the better? AC or DC? Okay. In DC, one conductor is positive and earth is taken as the negative polarity. Only one conductor. So remaining there are three conductor cost, copper cost. Okay, copper cost will be reduced. So DC is better sometimes. But nowadays AC is invariably used. AC is mostly used in our country due to DC. Okay, cost is low, but their construction, their maintenance is very difficult. Okay, in DC, in AC we are using substations. In DC we are using substation, but all power electronic devices, power electronics, rectifiers, converters. Okay, all advanced electronics. initial cost is high. This DC conductor cost is low, but maintenance and their maintenance, higher power plant devices, rectifiers, IGBTs, inverters, these are the maintenance is very high. So nowadays we are using AC in our country. Okay. Coming to overhead transmission system, underground system. Already know. Okay. Underground system is used cable. Cable nothing but insulation failure. Some voltage is behind that its insulation is better. So due to difficulties of insulation failure underground cable, it is limited to 66 kV. But our voltages are very high, 400 kV, 765 kV, 220 kV. So higher voltage requirement is needed. So that we are using overhead system is more. It is limited to 66 kV. Coming to scheme means method of connection. Radial system, ring main system, interconnect system. Radial system. Number one, radial system. Radial in single. Radial system. Radial system. Okay na? One substation. Different feeders are connected. Feeder. Substation. So this is the diagram of radial system. So what is means? Radial means single. So only one source. Single substation, different feeders. Suppose example, Abdullahpur Met is a substation. Abdullahpur Met is one substation. From Abdullahpur Met, different villages, Vatasangara, Vignan College, Avanti College, different villages are there. Only at the radial means single, only single substation, different feeders are connected. It is called radial system. Radial means single source. Only single substation, we are supplying different villages. It is called radial system. And the ring main system. What is the ring main? In the name itself, ring means loop. Okay. So in ring main system, that is second figure. Ring main system. Ring main system. Here also one single substation used, but it is connected in loop side, ring side. Okay? Only single substation. It is connected to what is the ring main system? What is the difference between radial system, ring main system? Here single substation used and power is distributed to different areas. Only single source. Here also single substation. Example, Abdullahpur Met is a substation. It is connected to different villages, but interconnected. Suppose if any village fault is occurred, that fault it is only that village fault is isolated. Remaining continuity of supply taken from other villages. So compare radial which one is the ring main system. The continuity of supply, consumer the continuity of supply is taken from it is connected single substation, but different areas is interconnected. Different areas is connected to a ring shape, or it is a loop shape. Okay. Suppose here this is the substation. This is one area. This is one area. This is one area. Okay. Now, suppose in case of this village, any fault is occurred, disturbance is occurred. This is completely isolated. Continuity of supply taken from other villages. So, consumer side, no interruption is taking place. Consumer side, no interruption taking place. So, continuity of supply taken consumer side. So, it is called ring system. It is used as single substation, but connected in a loop side, in a ring side. If any fault occurring one side, that is separately isolated. Continuity of supply taken from other side. So, supply is not interrupted to consumer. Supply not interrupted to consumer. So, ring system, that is. Third one is interconnected system. Interconnected system. Interconnected system also same. Only difference is here only single substations are used. But interconnected system, there is two types of sources are used. Two substations, substation 1 and substation 2. The application remaining same. Okay. Here two sources are used. Two substations are two power generation plants. Small power generation plants are there. Okay. Two types of sources. And here any fault occur in any side, that area only isolated, continuity of supply taken from other side. In interconnection system, instead of single substation, two sources are used. Okay? That is the interconnected system. The diagram is, this is the diagram. This is substation 1. This is substation 2. Okay. Substation 1 and substation 2, everything remaining same. Okay. So these are the loads. Okay. What is the difference there? Here single substation, different areas power is distributed. Here also single substation, different areas power distributed in a ring form, loop form. Here same ring form, but two substations are taken. Two substations are two small power generating power plant also. Small power plant also there. Okay? Here connection is taken from two sources, two substations, substation 1 and substation 2. Okay? So this is the basic distribution system. Okay? So distribution system is nothing but it distributes the power for local use. It is called distribution system. It is a part of power system. It will distribute the electrical power for local use. It is called distribution system. Distribution system generally consists of feeder, distributor, serviceman. What is feeder? Feeder is a conductor. It is connected substation to the area where the power is distributed. It is a main line. No connection, no tappings are taken. Or the connection is not taken, what happens? There is no voltage drop. Current is remaining same. So, by designing the feeder, current carrying capacity is our aim. Coming to distributor. Distributor is also conductor, but it distributes different gullies, different streets. So it distribute. Distribute means there is a drop, voltage drop. Here current is not same. Distribute to main consideration, voltage drop is the main consideration. Coming to service means nothing but service cables.